6.3, we are graphing square root functions and inequalities. Now, we've already talked about H and K several times throughout this year. H, is that the horizontal or the vertical translation? Horizontal translation. Which means that K gives us our vertical translation. If you look at the equation that's given to you, H and K are found within the equation. How do I know that a number is H? H is found under the square root. K is found outside of the square root. So in example 1a, negative 2 is outside of the square root. That means that negative 2 is representative of K, which means it's going to move vertically according to K. One other thing I want to draw your attention to. In the formula, it says x minus h. That means h is always the opposite of what it appears to be. So if I have an h value, you need to change the sign before you decide whether it moves left or right. K, however, is the exact same sign every single time. So in this case, K is negative 2, and I don't have an h listed, which means that h is really 0. Now, all of these graphs look like partial parabolas. They're either the top or the bottom of a turned parabola. As a matter of fact, this is kind of how we get our inverses of parabolas, is from square root functions. So, when we talk about this parabola, or this partial parabola here, it has to have a start point. That start point comes from HK. So when we go to 0, negative 2, there's our start point. And unless it's got some negatives going on here, it's going to extend to the right. We can confirm that in our calculators. So get your calculator out. Y equals and be very careful, make sure that you get out from underneath that square root sign when you type the minus 2. And you can see what I'm talking about. It's just kind of the top part of a sideways parabola. And you can get the other points from your table. Notice it has an error for all of these numbers. Why do you think it has an error for these numbers? Why not? What happens when I have a negative underneath the root? It's imaginary, which does not show up on a graph. So that's why. And you can see it's a starting point at 0, negative 2. Keep in mind, do not rely solely on your calculator to give you that number. Because if it's a decimal or a fraction, you won't get it and you won't have a start value. And your graph would be wrong. Okay? So plot your rest of your points. I like to go for the nice easy ones personally. Just enough to give me a shape. Notice there's only an arrow on one end of this because there is a start point. So let's talk domain and range about this. If there's a starting value for x, that means that my domain is not going to be all real numbers this time like we're used to. What would you say the values of x are here? X is greater than or equal to 0. It can be equal to because it's actually starting at 0. What about for y? Y is greater than or equal to negative 2 because it starts at negative 2 and continues to go up. Bless you. Let's take a look at the next one. Identify H and K in this case. H is the opposite of what it appears to be, so it's 1, and K is 0. Then you can type it into your calculator and get some other points. Now you can see with this one, when you graph it, it goes up much more quickly. And that's because of the 3 in front. The 3 makes it go up much more quickly. If it was a 1/3, it would be much skinnier than the one that we just saw. That A value in front just indicates how wide it's going to be. Use your table to get some other nice points. There's a nice point at 2 and 3. Another one at 5 and 6. And again, only an arrow on one end. That HK helps indicate our domain and range. Domain, X is greater than or equal to 1. And range, Y is greater than or equal to 0. Take a look at the next one and see if you can identify H and K. H in this case is -4. K is -1. Remember, H is always the opposite of what it appears to be. And your HK can always be confirmed by your graph. If you got that your HK was -4, -1, and your graph all of a sudden looked like this, when you typed it in, either you typed it in wrong or your H and K are wrong. So it can always be confirmed by what you have in your graph. What are some other nice points? 0, 0. What else? 0, 0. 12, 1 doesn't probably fit on there, but you could probably extend it to get there. I would argue that you could do 5.5. Any of those nice points, 12, 1 is fine. 5.5, that's fine as well. But notice how much slower it extends up, and that's because of the 1/2 that's in front. In our domain and range, X is greater than or equal to -4, and X or Y is greater than or equal to -1. The next one adds an extra challenge because H is not +5 in this case. If you notice in the original equation at the top of your page, there was no coefficient to the X when we just pulled out HK. The coefficient to the X has a special role when it comes to H and K. It becomes the denominator of H. So in this case, H looks like it would be positive 5, right? But in reality, it's 5 over 3. Whatever your numerator or your coefficient of your x is, that's your denominator of H. So when I go to graph this, 5/3 is 1.6 repeating. And again, it's confirmed by my graph. It looks like it's in the right spot, doesn't it? You can confirm that further if you go to value, second calc and value, and type in 5/3. It should be 5 for your K value. And it gives me 5. So you further confirm that, yes, that is the start point. Pull some other nice points from your table. I have one at 2 and 4, 3 and 3, and 7 and 1. Now this one has a little bit different shape. What do you think plays a role in the reason why this shape looks different? The negative in front. It makes it go from opening up to opening down. So my domain remains as greater than or equal to, and there's our H value, 5/3. But in this case, my range is not going to be greater than or equal to this time because it opens down. Less than or equal to 5. If you're going to just tell me what H is, like your H value, you mean? Like if I want to tell what H is, this number under here, this number in front always has to be 1. So how we do that is we move it to the bottom. Just like we're solving. What you're actually doing is solving. So you add 5 to both sides, divide by 3, and that's actually how we get our H value. We just don't always write that out because we can look at it and tell. Let's talk about inequalities because there's a couple of extra little things that happen. So you're going to do the same method for graphing a square root inequality, but we have extra things that happen in there. Dotted lines, shading, and we also have the issue of open or close dot for our start point. Okay? When we graph this, the same method happens. We need H and we need K. So in this case, H is -1. And K is -4. Now before I go and plot this, take a look at the equation. The inequality has an equal to sign. That indicates I'm going to use a closed dot for my start position. Oops, goes a little off the graph. Sorry, guys. So square root of x plus 1 minus 4. Here's what my graph should look like. Looking at my table, I can pull a couple of other nice points. 0, -3. The other points are just for plotting, so we don't care if they're open or closed. 3 and -2. And again, because it's equal to, I'm going to use a solid line to connect the dots. The next part comes with shading. It says that y is greater than. So would that be shading on top or below? On top. Now be very careful, because there is a barrier here. Because we said that anything to the left of here gives me a negative underneath the radical. So none of your shading should go that direction. Now I'm using a solid line in this case because it's got an equal to. If it was a not equal to, we'd use a dotted line for that barrier. But the barrier must always be drawn. There's our shading. When we talk about domain, we have x is greater than or equal to our -1, and y is greater than or equal to our -4. Again, equal to's, because that's what it indicated up here and by our solid lines. Next one. I've got a strange h and k again. H in this case should be a positive, not just 3, but 3/2. And I don't have a value for k, so that makes it 0. Now when I go to plot this, I should use an open dot because it's not equal to. 3/2 is about 1.5. And then get some nice points from the table. 2, 2. And if you want one in between there, yes, you could use 3.5 and 4. Now because I used an open dot, that means I should also be using a dotted line. Y is greater than, so that means I'm shading on top. So don't forget about your barrier. And it's not equal to, so it needs a dotted barrier as well. Now my domain should be x is greater than 3/2. And my range is y is greater than 0. Not equal to for either of those domain and ranges because they're not equal to in the equation. Last one, identifying h and k. H in this case gives me 1/2, and k is -4. When I go to plot it, I'm going to need an open dot for this because it's not equal to. And pull some nice points from your graph, from your table. 1 and -2. 5 and 2. And I can use a dotted line to connect this. Because I'm using an open dot, it's not equal to in the equation. This time it says y is less than. So my barrier is no longer going up because I'm not shading up. My barrier is only going down because I'm shading on the bottom. My domain is x is greater than 1/2, but my range this time is less than because I'm shading on the bottom. Actually, our range in this case is not an inequality at all because it continues up forever. And because I'm shading down, It continues down forever. So actually our range in this case is all real numbers. Y can be anything. So be very careful and pay attention to what your graph is telling you for your domain and range.